How does an AI know about things that happened after it was trained? It uses a powerful technique called RAG. I'm going to explain what RAG is using a simple analogy in the next 60 seconds. No code, no jargon. By the end of this video, you won't just understand RAG. You'll see why it's becoming the dividing line between a standard six-figure coding job and a top-tier AI engineering career. First, we'll visualize RAG with a simple librarian analogy. Then, I'll show you how companies use it to solve billion-dollar problems. Finally, I'll reveal the specific RAG-related skills recruiters are looking for and why one of them is the key to unlocking the highest salaries. But here's the first piece of value, the mental shift that changes everything. RAG is not a coding skill, it's a system design skill. Most engineers get this wrong. They rush to learn frameworks like LangChain, but the real value is in architecting the flow of information. Think of yourself not as a programmer, but as an information architect who decides which books the AI is allowed to read. This single mental shift is the first and most critical step. So let's move fast. 3 core ideas in the next 3 minutes that show you why RAG is the most important AI concept for your career right now. First, the problem, data chaos. Every company sits on a mountain of private information. Internal wikis, Slack messages, customer support tickets, code repositories. Public models like GPT-4o have never seen this data. They have no idea what your company's latest project is. RAG is the bridge. It gives a powerful AI model a permission slip to read your company's private library before it answers a question. Imagine a customer support bot that can instantly find the one sentence in a 1,000-page technical manual that solves a user's problem. That is RAG in action, and companies are desperate for engineers who can build it. Second, the mechanism, the smart filing cabinet. How does the AI find the right information so quickly? It uses a special kind of database called a vector database. Instead of storing documents alphabetically, this filing cabinet stores them by meaning. All the documents about billing are clustered together. All the documents about server errors are in another corner. When a question comes in, the system instantly goes to the right cluster of documents. Understanding how to organize this meaning-based filing cabinet is a skill that puts you in the top 10% of AI talent. Third, the opportunity. Most people think RAG is just for building chatbots. That's a huge misunderstanding. The real value is in complex, high-stakes decision-making. Think of a financial analyst asking an AI to summarize risk factors from 10 years of internal earnings calls, or a doctor getting an AI-powered summary of a patient's entire medical history, instantly highlighting potential drug interactions. This isn't about chatting, it's about augmenting human expertise. The engineers who can build these systems are not just programmers, they are architects of intelligence. So we have private data, a smart filing cabinet, and high-value applications. But connecting these pieces reliably is where the complexity lies. How do you ensure the AI sticks to the facts in the documents? This brings us to the most critical skill in modern AI engineering, grounding. Mastering it is what truly separates the highest paid engineers from the rest. Let's architect a RAG system together, not with code, but with a visual blueprint. Most tutorials skip this. They show you a library, but they don't teach you how to be the architect. Think of this process in 3 stages: the ingestion pipeline, the retrieval engine, and the generation step. Mastering the why behind each stage is what separates a junior coder from a senior AI strategist. First, the ingestion pipeline. This is how the AI learns your private information. Imagine a truck delivers 10,000 books to a new library. These are your company's documents, PDFs, and support tickets. You can't just dump them on the floor. A librarian has to process them. This is ingestion. The first step is loading, simply getting the books into the building. But the next step, chunking, is where most engineers get it wrong. You can't give the AI a 500-page manual for every single question. It's too slow. So the librarian, that's you, the architect, breaks down each book into smaller, meaningful paragraphs or chunks. This is the single most critical step in the entire process. Your chunking strategy determines everything. Do you split by paragraph, by page, by topic? This is an information design decision, not a coding one. Getting this right is 100 times more important than which vector database you choose. While everyone else debates database speeds, top engineers obsess over their chunking strategy. This is the hidden skill. Once the books are in smart, digestible chunks, the librarian performs the final task, embedding. She reads each chunk and writes a special index card for it. This card doesn't have words. It has coordinates, like GPS coordinates for meaning. Chunks about billing problems get coordinates that place them in the billing section of our meaning map. This process of converting text into meaning coordinates is called embedding. Your 10,000 books are now a highly organized set of index cards. The ingestion pipeline is complete. Now for stage 2, the retrieval engine. This is where the magic happens. A user asks a question. My payment failed with error code 402. The librarian doesn't read all 10,000 books. Instead, she converts that question into the same kind of GPS coordinate. Now she has two coordinates, one for the question and the ones for all the index cards. Her job is simple. Find the index cards with coordinates closest to the question's coordinates. This is called a similarity search. She instantly zips to the billing section of her map and pulls the 5 most relevant index cards. These 5 chunks of text likely contain the exact answer. Notice, the powerful AI model, the GPT-4o, hasn't even been used yet. All the heavy lifting was done by our smart filing system. And here's a truth that flips the common wisdom on its head. A perfect retrieval system fed to a decent language model will always outperform a world-class model that is fed garbage information. The quality of what you retrieve is the bottleneck. The top-tier AI engineer isn't the one who can fine-tune a model. It's the one who can architect a system that consistently finds the perfect piece of information at the perfect time. Your job is to be a master librarian. If you're starting to see how this is more about architecture than just coding, do me a quick favor and hit that like button. It's a simple click that tells me you're getting value from this blueprint approach, and it helps the channel a ton. This brings us to our final stage, the generation step. The librarian now has the 5 most relevant chunks of text. She walks over to a brilliant professor. This is our large language model. The professor is a genius at language, but has a critical weakness. He has no long-term memory. He only knows what's on the papers you put in front of him. The librarian hands him the 5 index cards and gives a simple instruction. Using only the information on these cards, answer the user's question. My payment failed with error code 402. This is the augmented part of Retrieval-Augmented Generation. We are augmenting the model's knowledge with relevant, just-in-time facts. The professor reads the cards. One says, error code 402 indicates an issue with the credit card's CVC number. The user should be advised to double-check the 3-digit code on the back of their card. The professor then crafts a perfect response. It seems you're encountering a 402 error. This typically means there might be a typo in the CVC number you entered. Could you please double-check the 3-digit security code on the back of your card and try again? Let's look at a real-world case study. An e-commerce company, InnovateMart, was drowning in support tickets. Their average resolution time was over 12 minutes with a team of 50 support agents. They built a RAG system. They ingested their entire knowledge base of 2,347 technical documents. Now, when a customer asks a question, the RAG system retrieves the exact 2 paragraphs from their documentation that solve the problem and feeds it to a Claude 4.5 model, which writes a helpful response. The result? Their average ticket resolution time dropped from 12 minutes to 90 seconds. After 3 months, they reassigned 15 support agents to more complex tasks, saving the company an estimated $847,200 in annual operational costs. The engineer who led that project was a business strategist who understood how to architect the flow of information to solve a $1 million problem. That is the power of thinking like a system designer. This entire process is about one thing: grounding. We are grounding the AI's answer in verifiable facts from our own documents. This prevents the model from hallucinating or making things up. It's the single most important technique for building safe, reliable, and trustworthy AI systems. The engineers who can build these grounded systems are becoming indispensable. They aren't just building features, they are building trust. Now that blueprint seems straightforward, but here is the uncomfortable reality most tutorials won't tell you. Building a RAG system that works reliably is incredibly difficult. Most initial attempts fail, not because the code is wrong, but because the strategy is wrong. Let's cover the most common mistake, because it's what separates successful projects from expensive failures. The biggest trap is focusing on the wrong thing. Engineers spend weeks debating whether to use GPT-4o or Claude 4.5. They obsess over which vector database is microseconds faster. This is a complete waste of time. The single most important factor is the quality of the information you retrieve. And that comes back to your chunking strategy. I saw a company learn this the hard way. They built a RAG system to help their sales team get instant answers about product specs during client calls. On paper, it worked. But they used a lazy chunking strategy, just splitting documents every 1,000 characters. This meant paragraphs were cut in half, sentences were severed. The system retrieved these broken, Frankenstein chunks of text. When a salesperson asked, "What is our enterprise security compliance?" the AI, using the broken text, gave a confusing and incomplete answer. The client got spooked. The deal, worth over $200,000, fell through. The company didn't have a coding problem, they had a librarian problem. Their system was built on a foundation of broken paragraphs. So, what does success look like? The proof isn't a single good answer, it's a dashboard. It's a graph showing your system's accuracy is consistently above 95%. It's a metric that tracks how often the system retrieves the perfect document chunk on the first try. It's a testimonial from a senior engineer saying, "I used to spend an hour a day searching our wiki for answers. Now I get them in 10 seconds. That is the real proof of a well-architected system. So here are 2 pro tips for getting there. First, build an evaluation system before you write a single line of production code. You need a set of 100 difficult questions and the perfect answers for them. Every time you change your chunking strategy or embedding model, you run a test. Did your score go up or down? Without this, you are flying blind. Second, the highest leverage activity is always improving the quality of your source documents. Garbage in, garbage out. Before you even think about AI, clean your library, standardize your document formats, add summaries and keywords. A well-organized library fed to a decent AI will always outperform a disorganized mess fed to a genius AI. This is the core work of a RAG architect. We started with a simple question. How does an AI know about things that happened after it was trained? The answer wasn't a complex piece of code. It was a system, a librarian, a smart filing cabinet, and a brilliant professor working in concert. Your one action item for today is this. Find a system you use that has a search bar, your company's internal wiki, or a site with great documentation. Ask it a very specific, detailed question. Then, for a moment, try to visualize the librarian. What specific documents do you think it retrieved to give you that answer? This simple exercise is how you begin to think like an AI architect. It's the mental shift from just writing code to designing intelligent systems, and it's the most valuable step you can take. If this approach to building your AI career resonates with you, consider subscribing. In the next video, we'll cover the 3 types of AI engineering roles and why only one of them is truly future-proof. Thank you for watching.